Alright, so basically the most important thing to learn for this chapter is Theorem 5.5, which states that the integral of 1 over x dx equals the natural log of the absolute value of x plus c. And then number 2, we have the integral of 1 over u, which u is a set of numbers. It could be any set of numbers. As long as 1 is over it, dx equals the natural log of that set of numbers plus c. A second formula can also be represented as this by using u substitution, which we will go over in some of the example problems.
In order to do example number 1, you have to take out 10 from 10 over x. And then apply theorem 5.5 to this problem. So the answer will be 10 ln x plus c.
Okay, in example number 2, we have an expression 6x minus 4 instead of just one number. So 6x minus 4 will equal u. Making this the integral of 1 over u integral of 1 over u dx. So the answer will be ln times the absolute value of 6x minus 4 plus c.
Alright, so for example number 3, we're going to introduce u substitution. U substitution works like this. You set the bottom expression equal to u, and then you take the derivative of that expression to make it equal to du, which is negative 3x squared. And then you want to make du equal to your numerator, or whatever you have left. So you're going to divide this by negative 3 to get du over negative 3 equals x squared. So then you're going to substitute u in for this expression and du in for this. So you're going to get the integral of 1 over u times du. Alright, so now since we have negative 1/3 left over, we're going to put it in front of the integral sign. And then since the integral of 1 over u equals the natural log of the absolute value of u, we're just going to write natural log of u times negative 1/3. So now for the final step, all we're going to have to do is substitute u back in, and we will get our answer. Seven minus x cubed plus c.
So for u, you want to plug in the denominator, which is 2x cubed plus 5x plus 2. And then take the derivative, which would be 6x squared plus 5 dx. So since the numerator is the same as the derivative of u, you can simply plug in the equation 1 over u du. So now using the formula of the integral of 1 over u, you get the natural log of u. And then you simply plug in u and add plus c.
Like the previous problems, we'll be using u substitution in this problem. So u equals 4x squared plus 4x. And du, which is the derivative of u, equals 8x plus 4. And using simplification tactics, you're going to remove 4 from that, from du. There's going to be 4 parentheses 2x plus 1. And you're going to divide both sides by 4. And since du over 4 equals the numerator, then theorem 5.5 applies. So 1 over 4 integral of 1 over u du. And then that's theorem 5.5, so it's the natural log of the absolute value of u plus c. And then you're going to substitute u in. This is the natural log of the absolute value of 4x squared plus 4x plus c.
For problem number 6, we're going to need to use a different method, long division. So we are going to have 2x squared plus 7x minus 3 divided by x minus 2. To start off, we will multiply x minus 2 times 2x to cancel out the 2x squared. This will make us get 2x squared plus 7x minus 2x squared minus 4x. Parentheses. The difference for this will be 11x. Then we will drop the negative 3, so we get 11x minus 3. Now we will multiply x minus 2 times 11. This will get us 11x minus 22. Then we subtract it from 11x. This will get us 19. Therefore, the integral of 2x squared plus 7x minus 3 over x minus 2 equals the integral of 2x plus 11 plus the remainder over x minus 2, which is 19 over x minus 2. dx. To solve this, we will get x squared plus 11x then using our formula, we will get 19 times ln, absolute value of x minus 2, plus c.
Alright, for example number 7, we have the integral of the denominator of 2x over the denominator squared. Since the denominator is squared, we're gonna set u equal to what's inside x minus 1, and we're gonna set du equal to the derivative, which is just dx. Since we still have 2x left over, we're going to have to use what's called the change of variables rule, where we have to solve for x instead of u, so you can plug it in for the 2x up top. So we're going to add a 1. We're going to add a 1 to u, so x is going to be equal to u plus 1. So now we can just substitute x in for the 2x, so we get integral of 2 times u plus 1 over, since we have x minus 1 is u, we can just say u squared. Alright, so now we're going to multiply u plus 1 by 2 to get 2u plus 2 over u squared. So now that simplifies to, you can change that to be the integral of 2u over u squared plus the integral of 2 over u squared, and we can simplify, or we can take out a 2 on both sides to make it the 2 integral of u over u squared, which is also 1 over u if you simplify it, plus 2 the integral of 1 over u squared. So now, the integral of 1 over u up there is ln of the absolute value of u. then you drop the 2 down, plus. And now we can change 1 over u squared to be just u to the -2 to make it easier to integrate. So that's just going to be 2 times u to the -1 over -1, which is just negative u to the -1. So now you're going to multiply that 2 by this negative u times to the -1. So we're going to end up with 2 natural log of the absolute value of u plus 2 or -2 u to the -1, which can also be written as 2 natural log absolute value of u plus negative, or since it's plus minus, we can just make this a minus. Minus 2 over u, 2 over u. Alright, so now we have 2 u's, which we can substitute back in for the original x minus 1. So for our final answer, we get 2 natural log of the absolute value of x minus 1 minus 2 over x minus 1.
Yeet.
Alright, before we advance to our next problem, we're going to introduce to you the 6 basic trig function integrals that you need to know. Take a minute to write these down on a piece of paper. Using the basic trig identity cotangent x equals cosine x over sine x, we will then substitute sine x for u. And then take the derivative, which will give you du equals cosine x multiplied by dx. And now substitute sine x for u, and you get your answer.
Hey, what do you know?
For number 9, we're going to use basic trig identities to translate cosecant to 1 over sine and cotangent to cosine over sine. Then use keep change flip to get 1 over cosine. One over cosine equals secant x. Using the 6 basic trig function integrals, secant u du equals natural log the absolute value of secant u plus tangent u. Plus c.
Actually, it's x.